The need area we're focused in was ventilator-associated pneumonia, which is a lung infection in a patient that's been mechanically ventilated for more than 48 hours. The need statement that we kind of use now that I think was pretty close to what we ended up with was an aspiration barrier that can be applied post-intubation in the ICU for any high-risk ventilated patient. For like the disease mechanism, we looked into the space, and VAP is multifactorial, but it's pretty well established at this point that aspiration of saliva that has bacteria in it, saliva or stomach contents into the lungs, is what ultimately leads to pneumonia. So the mechanism is understood, and a lot of technologies exist in the form of improved endotracheal tubes to prevent that. But as we kept looking into the space, we were really surprised by how little they're adopted.
The moment things shifted was when we realized that it wasn't about the need, the medical problem itself. It was more about the alignment of providers and the different players and why the current technologies were actually not used.
Endotracheal tubes are placed primarily in the operating room or in the emergency setting, but 95% of patients that are intubated with a tube are just on it for short term. They get extubated after a few hours. Just 5% go on into the ICU. So, the anesthesiologist is placing the tube and making the purchasing decision on which one to use, but a tiny fraction of their patients go into the ICU, need protection from VAP, so they're not really incentivized to spend that money up front, and maybe they're not as aware of it.
The ICU providers are the one who are going to see and have to deal with VAP and all the consequences and the costs, but they don't have a say into the upfront decision. We did a bench test where we essentially took a pig trachea, put a tube in, poured some dye over it, and figured out how much was actually going through and try to see how good of a seal those endotracheal tubes were. And I think at that point, when we saw how bad they were, that actually really drove home the aspect of, well, we can really improve this portion of things. I think that video was also very convincing to different people, different advisors who really said, wow, I didn't think it was that bad of a solution, the one that we currently have. So I think that helped solidify the need itself.
I think some other things we did was, a lot of literature searching. So we talked to clinicians at Stanford and that we could get in touch with. We found literature from all over the world showing that VAP is still a very real problem. The other thing that I think helped us feel that there was something there was the fact that so many big medical companies were still coming out with improved endotracheal tubes. Covidien, Kimberly-Clark, Teleflex were still trying to improve on the endotracheal tube to reduce VAP. I think a lot of people who have looked at this space started with a need statement that was something like, an improved endotracheal tube to reduce the risk of aspiration. But instead, when we were scoping it out, we removed the technology from the statement, which is, Biodesign 101, and instead just said, we need an aspiration barrier that can be applied. And then as we went in and started talking to users, we observed patients in the ICU, we observed the intubation process, which is a very high stress situation. I thought, well, you know what, I think one of the user requirements is that whatever the technology decision is, it has to be made post-intubation. And so that went into kind of our user specs, which helped us in brainstorming come up with, technologies that were adaptable. Our general concept that we came up with was a secondary balloon cuff that's independent of the endotracheal tube. So it's basically a donut balloon that can be advanced over the endotracheal tube down into the trachea to create a very effective seal. And by detaching it from the endotracheal tube, we have a lot of flexibility in the materials that we use, the shape, and so we were able to optimize that truly just for sealing, not for any, it's a seal, it's a aspiration barrier.
I think if there are that many people trying to push their product and there are all these parallel solutions, it means that there's still a gap. If there was one fantastic solution for this, they would have 95% or 99% of that market, and it would be, a commodity or whatever. Or the fact that you have all these players trying to sell their solution. Actually, I think it validates the need and the market.